Okay, today we're going to talk about hydrates and how we name hydrates. So let's look at hydrate first. So a hydrate simply means water. So basically, if you have a hydrate, this is a compound that has water attached to it. So on your periodic tables, you guys can definitely put the following table, 11.1, onto those. So let's look at naming these. So first off, hydrates are going to come with ionic compounds 9 times out of 10. And so when we look at these, we still have to name them. So NaCl is going to be sodium chloride. We're not going to change how we name the ionic compound. The only thing that's going to change is we're adding a hydrate to it. The number in front here is going to be how we name like a covalent compound. So 5 is penta. And in this case, we have water. So instead of putting penta water after, we're going to put pentahydrate. So same thing down here. We name the compound, so it's magnesium and chloride. We look at the water molecule here. 4 Tetra Hydrate. Same thing down here. We name the ionic compound first, so it's calcium. SO4 is a polyatomic sulfate. And then we look at this number right here. Look at our chart. 3 is trihydrate. Then let's do our last one. So CuSO4, so this is copper. Copper is a transition metal. So because it's a transition metal, we have to put the charge for that. So we know sulfate is a -2 charge. And we can look down here. Oh, this tells us right here. This is a copper 3. And then we name our polyatomic sulfate. Now let's name our water. So we look at the 2. If we look at the table that I asked you guys to copy, to di, and it's hydrate. And so that's how we name these. So why do we have these hydrates which seem to be so different than everything else? So if we look at copper sulfate dihydrate, copper sulfate, when this is in its hydrate form, it's a beautiful blue color. It's gorgeous. If we would heat it up, the hydrate or the water molecules get removed because the water is going to evaporate. The ionic compound cannot just evaporate out. And so an ionic compound has a much higher melting point than water, and so the water will evaporate out. This will actually turn a whitish color when it is something that we call an anhydrous. Anhydrous, an meaning anti, it means it has no water in it. So when you hear a term called an anhydrous in this case for the copper sulfate dihydrate, I'm sorry, this should be di as I'm looking here, that would just be simply copper 3 sulfate. That's all it is. There's no water molecule attached to it. And so if we would leave this copper anhydrous sulfate up and just we evaporate all the water out and we just leave it on the desk and we leave it at room temperature, what would happen? Well, the water molecules that are actually in the air, and if you have a good humidity level, within 24 hours, you're going to see that blue color pop back. If we actually take a water bottle and we spray it down, you'll see it turn blue right away. And so you're actually going to determine how much water is going to be in there. So the next part of this lesson is going to determine how much water we have in these hydrates and how we write this hydrate formula out. And so that is part 2 of this lesson.